This is day 20 of Unit 7. We started today with this warm-up, so pause the video, try the warm-up, then play to check your answers. So finding the inverse, so I know I need to change that g of x to y. And then we know from yesterday's lesson that we have an exponential, and in order to get the inverse, we're going to have to use logarithms because the inverse of an exponential is a logarithm. So I'm going to put this into log form. So I write log, I copy the base, and then if you want to use the little circle trick I showed you yesterday, 3 to the x equals y, so log base 3 of y is equal to x. Now I've put the equation, the original equation, into log form, but I haven't found the inverse yet because remember the inverse, the last step is interchanging the x with the y. So log base 3 of x is equal to y. And then just lastly, remember we want to make that g inverse of x. So g inverse of x is equal to log base 3 of x. And that is our equation for the inverse of the original exponential, y equals 3 to the x. Okay, so today, the first thing we did, and this is, actually we started with page 9, and we just briefly talked about some of the things mentioned there. Basically what we talked about was that the base the calculator uses is base 10. So when it has the log of 100, first of all, notice that there's no base written, and we talked about the fact that when there's no base written, you are to assume that we're dealing with base 10. It's kind of similar with square roots. When we see that symbol and there's not a number there for the index, we assume the number is a 2 because we assume it's a square root. Same thing, when there's no base written, the log has base 10. So if I'm trying to figure out what the log of 100 equals, which is on page 9, I'm basically taking 10 to what power to give me 100, and we know that 10 squared equals 100, so the log of 100 is equal to 2. Okay, and again, that's because there's no base written, so I know it's base 10, and 10 squared is equal to 100, so the log of 100 is equal to 2. Okay, so then you're going to just do the rest of the problems on the bottom of page 9. Really just using the same operations that we did yesterday, going from log form to exponential form to solve those, or from exponential form to log form, just going back and forth using the little circle trick if you prefer. So you'll have to do page 9. We didn't really do that together in class, the bottom of page 9, but you can go ahead and do that as part of your homework for tonight. After that, we did turn the page to 10. And we did this activity where the first thing you want to do is to fill in the table. And I just said you're going to use your calculator to do this because these are all base 10. So this is log of x, meaning it's base 10. We did do the first one without a calculator. The log of 1, remember we said the base is 10. So 10 to what power gives me 1? Well, we know that that's 0. Okay, so the log of 1 is 0. And then we also talked about the fact that anytime I have a log of 1, regardless of what the base is, the base could be 2, 3, 4, so forth, it doesn't matter. The log of 1 always equals 0 because any number besides 0 taken to the 0 power always gives me 1. So then the rest of these, we just use the calculator to fill in the values, and it does say round to 3 decimal places. So just pause the video a moment, take a minute to fill in this table so that you have the values, and I'll just start filling them in. 7. Okay, so now I have the values. So then the next thing we did here in part 2 was just use the table. So go up to log of 3, which is 0.477, and add it to log of 2, which is 0.301. And when I do that, when I add the 0.477 to 0.301, I'm getting 0.778. Okay, next I'm going to do 3 times 2 is 6, so I'm going to look at the log of 6, which is 0.778. Again, I'm just using the table to get that. And we're noticing, oh, they're the same. Okay, well, that's one number example. Let's see if it holds true for some other examples. So the log of 1 from the table, that's 0, plus the log of 4 is 0.602. And when I multiply 1 and 4, I get 4. So I'm getting the log of 4, and I go to the table, and the log of 4 is also 0.602. Okay. Continuing on, the log of 2 is 0.301. Whoops, 301. And we're adding that to the log of 4, which is 0.602. And when we do that, we get 0.903. The log of 2 times 4, well, that's the log of 8. And the log of 8 is 0.903. Okay, so you've probably figured out the pattern at this point. So we should be able to complete this statement. The log of m plus the log of n is equal to the log of mn. Okay, and you'll notice, and you've probably already noticed in the homework, sometimes there's parentheses around what we're taking the log of, other times they're just not inputted. So it doesn't really matter. Always what follows the word log is what you're taking the log of. So whether the parentheses are there or not, it doesn't matter. But the property says the log of m plus the log of n is equal to log of mn. So the next thing I had students do in class was use the table to fill in parts 3 and 4. So what I'd like you to do if you're watching this video and you haven't done this page yet, page 10, I'd like you to just pause the video and fill these in and then play to check your answers. Okay, so hopefully you did fill these values in for sections 3 and 4, and you should have realized that the log of 2 minus the log of 1, whenever you figured out that value, was equal to the log of 2, which was 2 divided by 1. The log of 4 minus the log of 2, taking those two separate values and subtracting them, was the same thing as the log of 2, 4 divided by 2. And the log of 6 minus the log of 2 was the same thing as the log of 6 divided by 2, which is the log of 3. And so that should have helped you realize that we can complete the statement, the log of m minus the log of n is equal to the log of m divided by n. And then the last section, same thing, 3 times the log of 2. And I'm not going to take time to fill these values in because you can use a calculator and type them in and get those. When you got that value, though, 2 cubed is 8. The log of 8, that value was the same as 3 times the log of 2. Same thing with the next one, 2 times the log of 3. Well, log of 3 squared is 9. The log of 9 was the same as 2 times the log of 3. And lastly, 4 times the log of 1 was the same thing as the log of 1 to the 4th, which is the log of 1. So you should have realized that k times log of m is equal to the log of m to the k power. Okay, so the next thing we did after we went through that was we answered questions 5 and 6. So it says, 5 says, how could you use the statement from 4 to evaluate log of 1,000? Well, log of 1,000, we're going to rewrite that using exponents. So that's log of 10 cubed. And now we're going to use this statement from 4, which is the property. We're going to bring that 3 down front, 3 times the log of 10. We already mentioned earlier that the log of 10 equals 1 because 10 to the first power equals 10. So I have 3 times 1, and 3 times 1 is 3. And number 6, what should be true about y equals the log of x cubed, the graph of that, and y equals 3 times the log of x, well, hopefully you realize that they should be the same. They should have the same graphs because of this property that we just went over a moment ago. Okay, so the next thing we did as we looked more closely at those properties. So those three properties that we just went over, they each have a name, and there's two different parts to those properties. There's the condensed version, and there's the expanded version or form. So on your paper, I think we have the condensed part goes on the left, and the expanded part of each one goes on the right. So if you're looking at that first property that we realized on page 10 in part 2, that first property that involved two logs being added or one log with the numbers being multiplied, just looking at those two different forms, you can probably see one looks more condensed than the other. One looks more expanded or spread out. Just by looks, you can tell that. So hopefully you are realizing that the condensed form of the product property, that first property, looks like this. The log of mn. That's the condensed form. Now, we looked at it because we wanted to use our calculators and get the decimal values. We looked at it just with base 10. However, these properties apply for all logarithms. So to indicate that we can use any base, we're just going to put a b there, meaning any base. Now, of course, bases can't be 0 or 1, but any base besides 0 or 1, these properties apply for. So that's the condensed form. Now, we know that that's equal to the expanded form, which again looks more spread out or expanded, and that would be two logarithms that are being added. Okay, so that is our expanded form of the product property. We also have the quotient property, which was the second property we looked at. And again, you can sort of tell just by looking which form is which one's the condensed and which one's the expanded. The condensed form, again, I'll use base b because it could be any base, is the division of the two numbers. And it's one single logarithm. The expanded form has two logarithms being subtracted. And that property is our quotient property. The third property is the third one we looked at a moment ago that involves powers, so it's called the power property. Now, the power property of the three, it's the hardest to tell the difference between the expanded and the condensed, because for both the product and the quotient, the expanded had two logarithms, and the condensed only had one, a single logarithm, so it was easier to tell that that was condensed. For the power, it's a little bit harder because both the condensed and expanded forms have just a single logarithm. So the condensed form is the one that involves the power. So the log base b of m to the k power is the condensed form. And that's equal to the expanded form, bringing that k down front, times the log base b of m. That is our power property. And then again, that's the expanded form on the right. Okay, so those are our three properties. The next thing we looked at in class is how we would use those properties, how we apply them. And so that's what we're going to do right now. So we did do a couple of these together, and then we just worked on some of the rest individually. But we did do the first expanding. So log base 5 of x over y, well, you can see hopefully that is the quotient property, and I'm expanding that. So I'm going to rewrite that as the log base 5 of x minus the log base 5 of y. That's A. We also did B. So let's take a look at that. So I have the log base 7 of a cubed b to the 4th. And we want to expand that. So there's two different things happening here. First of all, we have powers, but we also have the numbers being multiplied. So we have product property and power property. Now, when you're doing ones that involve multiple steps and you are expanding like we are here, reverse order of operations is followed. So expanding is reverse order of operations, where condensing is just normal order of operations. The reason I point that out is because we're expanding and we are reverse order of operations, that means the exponents will come last, meaning I'll apply the power property last and I'll apply the product property first. So my first step is going to be log base 7 of a cubed, and I'm going to add that to log base 7 of b to the fourth, applying that product property first. Now that I've applied the product property, now the power property is going to come next. Exponents come last when we're doing reverse order of operations. So 3 times log base 7 of a plus 4 times log base 7 of b. And that is my answer. Okay. Now, for C and D, we skipped those at first in class, and then we went back later. So I'm going to skip those for right now, and I'm going to take a look at condensing. So I did a couple examples in class of condensing. So let's take a look at A under the condensing section. So remember, we're following normal order of operations. So log base 3 of 20 minus log base 3 of 4. And I have to apply the quotient property here. So that means log base 3 of 20/4. And 20/4, of course, is 5. So my answer is the log base 3 of 5. We also did B. So I'll do that as well. So we have 3 times the log base 2 of x plus log base 2 of y. So I'm first going to apply the power property, because remember, normal order of operations, so that would give me log base 2 of x cubed plus log base 2 of y. And next I'm going to apply the product property. So log base 2 of x cubed y. And that is my answer for letter B. Okay. The rest of those, C and D from the first section and C through E of the bottom section, the rest of those I just kind of gave students time to work on in class. And in most of my classes, we didn't get a chance to go over those, so I will do that tomorrow in class. So what I'd like you to do for homework is to finish up page 9. We did the top of 9, but we didn't do the bottom, so you'll need to do that for homework. I think we did do all of 10, but if not, finish that up as well. And then 11, as I just said, we did most of 11, but there were those couple problems that we did not do, so finish that for homework as well. So basically, I want you to finish up what we did in class, whatever you don't have done, and then for homework, you're going to do pages 12 and 13. Coming up later this week, you do have a short quiz, so make sure you get ready for that.